All right. Good afternoon, and thank you for joining our session. My name is Martin Ganholm, and during the 6 years that I've been at Google, I've worked on and led the teams that have delivered a number of the cloud products you might be using, like Compute Engine, Container Engine, and Kubernetes.
Hi, I'm Louis Ryan. I've been at Google about 9 years now. I've worked on Google's API platform, so when you make API calls to Google, all of those go through stuff that my team works on. And also more recently, I've been doing a lot of work on gRPC. But I'm going to hand you back to Martin, who's going to show you some interesting stuff.
All right. So what we're going to talk to you about is based on a lot of our experiences building and running large-scale cloud services at Google, and how we can bring this kind of learning to Kubernetes and you folks. So there's been a lot of talk over the last few years about zero ops and serverless computing, and how these concepts allow you to spend less of your time managing and dealing with infrastructure. In effect, they can let you run ambitious apps at scale without having to know all the details. So if you use Google App Engine or BigQuery, you're familiar with how they allow you to focus on your expertise in writing your business logic or your data processing and not managing all the machines underneath the covers. So that's kind of the context. So we're going to talk to you about some technologies that are currently under development in open source that will get you on the way to being able to operate systems at scale, cheaply, efficiently, and securely. So we consider these building blocks the beginning of a journey to deliver the promise of zero ops and serverless computing in the integrated hybrid cloud. So all the different parts of your solution stacks, whether they're running in-house on-prem, or if they're in a public or private cloud, whether you wrote the components or whether you acquired them from some third party, it'll cover all of those pieces. So there are three intertwined principles that we believe are the foundation that will get us there. The first is services, not infrastructure. And what we mean by that is we need to look at a service abstraction layer. And if we do that, we can get away from dealing with the infrastructure. It's very common for companies to have, in recent years, to have a service catalog that make it easier for their application developers to sort of get bootstrapped with different pieces. But oftentimes, those are just a piece of infrastructure, like a virtual machine that gets provisioned, some deployment system or scripts run and install things on them. And at that point, it's yours. It's very much like getting a free puppy. And you quickly learn that getting the puppy was the easy part. You now got to take care of it. In contrast, offering managed capabilities behind an API is the kind of thing that has allowed for the explosive adoption of cloud services. And we'd like to bring that same kind of thinking to all the different components that you build or that you acquire from other people. So choosing an abstraction layer and getting it right means a few things. You'll be able to separate the construction, the operation, and the usage of components from each other, which gives you more flexibility in how you source the components and how you manage them. You'll be able to inject key behaviors in different control points in this higher level system, allowing for many of the intent-based functions that will let you operate at scale with little or no effort. You'll also be able to compose your solutions across a wide range of infrastructures, of environments and technologies. And this really brings us to the next principle, interoperability. This is fundamentally about choice and flexibility, about giving you a path from today to tomorrow and to whatever the future may bring. This includes legacy components that you already have running, that you use, in-house developed services that might be more modern, third-party software as a service pieces, and all of these will span multiple different environments. And it's all about allowing you to choose the best option for each individual piece without giving up on the promise of zero ops and serverless. And this is a vision that is only realizable if we succeed in the third pillar. We like automation at Google. We think that teaching computers to execute repetitive, error-prone, and large-scale tasks so that humans can focus on value-added pursuits is a good thing. So for example, if you want to apply an enterprise-wide policy to all of your services, that should be trivial. Do you want to canary test an update and then roll that out to all of your zones or whatever geographical spread that you have? If no anomalies are detected, and do that automatically, yep, that's one of the things you want to do. What if something wasn't right? Automatic rollback. So the answer for us is automate everything. So let's touch on two of the harder problems to solve for. I mean, let's just say it, networking is hard. Doing networking right is harder. And now you want it to be secure? You got to be kidding. Nobody wants to deal with that. At least I don't. But we talk about this as the space between the microservices. So the red lines here represent that space. And so the questions are, how do you securely connect services together? Can you do encrypted and authenticated access? Can you protect against DDoS or even just unintentional packet storms? Credentials, that'd be great if you can flow credentials through the system, but not just once. You want key rotation, right? You want these things to update and manage that. So those are the kinds of things that would be better if you didn't have to deal with. The second part is hybrid cloud or multi-cloud. That can be hard. If you use a homogeneous system like Kubernetes, for example, which is multi-platform, you can run it in many different places. And if you're all in on that, everything's fine. But most people don't have that luxury. So you have legacy, you have virtual machines. Those are the kinds of things that you have to sort of include as you evolve. So some of the questions you might have is, well, if I'm using a service on-prem, is that different? Do I have to operate it differently? Do I have to deal with it differently than a third-party acquired service? How do I tell which services I'm actually dependent on across my entire solution? How do I enforce company policies across those? Or can I only do it on a subset that I have under my immediate control? And how do I get a handle on the security aspects of this layout? So let's get more concrete and talk about the service abstraction. So we have partnered with several other companies around the Open Service Broker API, which is a relatively new standard in the making, which originally came from Cloud Foundry. So those of you familiar with Cloud Foundry will recognize these concepts. And so we're working with these companies on adopting and then extending this great abstraction. And so the importance of a standard is that services that are written for consumption in a Cloud Foundry application will be able to be used unmodified from Kubernetes with what we're going to show you today, and vice versa. And so as people adapt their services to this model, the amount of places you'll be able to use them is going to be great. All right, so let's pretend that I am a service producer, and I want to package up Google's cloud services behind the broker or inside the broker so that people can easily consume them. So we want to expose our cloud platform APIs, like you see them down there, cloud storage, PubSub, BigQuery. And so a broker can have multiple services that it's able to be a factory for, essentially. So let's look at one of these, Cloud SQL. So Cloud SQL has two types of instances. If you look on the Cloud Console, it has a first gen and a second generation. The broker API has a notion of a plan. Each service class can have one or more plans. And so as a producer, I might choose to use Gen 1 versus Gen 2 as my as the two plans that I can offer you. So when you want to get one of these, you choose which plan you want, and I can sort of make that bifurcation there. Alternately, I could choose a different way to factor it. I could say, well, what if there are different fundamental sizes, small, medium, large? I could do that. That's another thing you can do with the plan. Or a different type of way to look at it is, what about standard versus high availability deployments of Cloud SQL? So those are different choices that as a service producer, I have a lot of flexibility with this API to specify. So when you go and create a service instance, so you have a service class you want an instance of, you want to use it, so you create a service instance. You also specify which plan you want. And so here are some screenshots from Cloud SQL, and you see on the left are the options for Gen 1, and on the right there's a long scrollable list of options on Gen 2. And so the Service Broker API allows for the difference between these two things. And in the future, the parameters that are valid for one plan versus another will be schematized, and so that we can then automate, we can actually have the user interface parse through that and present you the options really nicely, and be able to show you what options are valid for which plan. So once you've created a logical instance, you want to use that service from an application. And rather than copying API keys, IP addresses, configuring SSL, and all those kinds of things that you today do in the Cloud SQL, in the Cloud Console, and then take whatever information they give you and apply those somehow to your code, to your config of your applications, the Broker API, in conjunction with another piece, the service controller, which I'll get to in a second, has a way of configuring and passing this information directly into your application, saving you sort of that step. So to illustrate this further, the service controller is a logical construct, and it's tied to your runtime environment. So here you can see the dotted box is meant to be a Kubernetes cluster, and so inside of that there's a service controller that understands what it's like, what it means to be a Kubernetes application. So it sort of does some of the work in this scenario. So the service catalog has a few purposes. One, you can register brokers with it, as many as you want. What it does is it asks the brokers what are the available service classes, and then it sort of creates an aggregated catalog of those things. Additionally, the service controller can let you, and this functionality doesn't exist today, but this is one of the things that we're looking at, is that this is now a control point where you can apply IAM policies, so that you can say, well, certain people can't access the user service. I can sort of lock that down. So they can't bind to instances of it, or they might not be able to create instances of it. So once a user decides which service they want to use, for example, let's pick Cloud Pub Sub, they ask the controller to create an instance of the class. And the controller delegates to the broker and says, hey, why don't you create this class? Create an instance from it. And then that in turn goes and does whatever it does. Completely opaque. You have no idea what it does. It could provision a large amount of virtual infrastructure, many virtual machines or whatever, or it could simply just insert a row in a database noting that you now have a virtual instance. So this is a nice abstraction because it allows the service provider to do whatever implementation they want, and it's transparent. So let's see. Okay, so now we have the service, and now we want to bind an application to it. We want to use it from an application. So here's an application, just a Node.js application in our Kubernetes cluster, and we want to tell the system that we want to bind these together. So we talk to the service controller, create a binding. The service controller once again delegates to the broker. The broker figures out what are the coordinates, where is the actual instance, what IP address, which port, those kinds of things. And again, it's service dependent, but that's a very common type of thing that it returns. And it also returns credentials. Credentials that could be unique for each binding, or could be shared for all the bindings to a particular instance. Again, this is a service. It's part of the service definition. So as a service producer, you can choose what makes sense in your scenario. And the last step that the service controller does is that it sort of creates the virtual binding and injects those credentials and those coordinates into the application so they can very easily consume it. And I'll show this in the demo in a few minutes. So yeah, in Kubernetes, this is done through secrets and config maps, and the application just accesses them through environment variables. Okay, so here are the pieces we're going to talk to today. So these are 3 different open source things. I talked about the service broker. I hinted at the service catalog. That's what I call the service controller. So the service catalog is a special interest group that's part of Kubernetes. So we're doing work there in the Kubernetes community to add that capability to Kubernetes. And Service Mesh is something that Louis will get into depth on, and it's another open source project that we're engaged in. It's actually called Istio, but we'll get to the URLs for that later. All right. So what these do, we talked about what the broker does. It's a core service abstraction, and the catalog basically provides environment-specific help to sort of get consumption of services to be something that is very natural in an environment, in this case Kubernetes. And the mesh is for traffic management and inter-service policy controls. Okay, so this is the application we will show you in the demo. What we have here, the gray boxes are existing microservices in my deployment, and so what we're going to do, the application, the purpose is to have a bookstore, to sell some books. So we want to have a front end that shows you the books and allows you to buy them. It's a very, very, very simple app. And I suppose we're already selling other items, sneakers or something else, and that's why we already have these inventory and payments connections. So we'll add the books front end application. We'll bind it to the existing microservices, and then we'll get to PubSub in a second. All right. All right, so can we please switch to the demo machine? It went to sleep, so I'm going to have to... Okay, so here's the Kubernetes dashboard, and we have a few new things on the left here, a little service catalog. And here we can see the service classes that are available for creation. If we look here, there's a couple of catalogs. There's a K8S1, which is really our department catalog. These are the microservices that we've built in-house, and we've sort of put them in a broker, in a catalog there. But we don't need to create any of these because we already have some pre-created instances for the purposes of this demo. So what I'm going to do is I'm going to switch over I'm going to run a script to install the application. So this is really just creating a deployment in Kubernetes using a YAML file, but I've just wrapped it up in a shell script. And so that will do some work. There we go. We have created something. And so if I say kubectl get pods, we will be able to see, oh, here we go, books FE. So this is my new deployment here. These are some pods, and we have an error. Shucks, what is that? Let's take a look. Okay, deployments, here we go, red text. So it says secrets books FE users not found. Okay, so why is this? Well, turns out there's a good reason for this. So here's a little bit of the source code of, oops, that's not what I meant to do. This is a little bit of the source code of that front-end application. And some of the stuff that it does here is it tries to access some things in the environment. And these actually come from secrets. And so the secret doesn't exist because we haven't created the binding. So one of the things that happens is when you create a binding under the covers, the service controller, because it's Kubernetes, says, well, I'm going to propagate these things in a secret. And then the application is configured to expect that secret to exist. And those environment variables get created from the values in the secrets. And so Kubernetes will just not launch these pods if all the dependencies haven't been satisfied. So we will go back and just create some bindings. So I'm going to go in here, and for each one of these, for most of them, what I'm typing here is this is a label. So in Kubernetes, everything is done, specifying what you want to address is all done through labels. So our label for our application is books FE. And I have to do this 3 times, so I'm going to copy that. So it's inventory. Oops, that's the one I did. All right, we don't need to do payments, we'll do purchases. And then we will do the last one, which is users. And what I didn't show you, if I did a kubectl get secrets, you'll see that it has a bunch of them now that are, it has a couple that are a few seconds old. Books Iffy inventory, purchases, and now there's one called users. So that one just got created. So now those secrets exist, and let's see what's going on with our deployment. So now when we go back, we'll see that the deployment is actually now running. So Kubernetes just figured that out, that now those dependencies are satisfied. So we have a front end, and so now I am going to launch my app. I'm going to launch the web browser for this app. All right. Oh, yes, it works. Okay, so here's my front end. I have some books. It's getting from the inventory, and I'm just going to buy one of these. This is a classic book, and let's buy this Crockpot Recipes, and I can look at my purchases and see that I have a couple of things right there. So let me show you one thing. I am going to show you the secrets, just so you can see how those work. Secrets, and then I'm going to say kube control. I'm going to describe that. I'm going to look inside of it, and I'm going to pick one of these. Oops. Oh, describe secret. That was, oh, of course. I'm just going to do this. I'm going to cheat. There we go. I forgot the OYAML. Okay, so here you can see some of the data. So the host name and port are being passed in, and that came from the binding. So those originally came from the service, and the controller injected those into the application through secrets and environment variables. All right, so now we're going to make a modification. So say that we're selling books. Our publishers are very interested in, well, let us know when you sell some books. Cloud Pub Sub might be a good way. If we publish events, they can just subscribe to those channels and look at them. So in order to do that, what I want to do is I want to go back to the service catalog, and I don't have Cloud Pub Sub. So I'm going to add one. I do it up here, add catalog. So I'm going to create one called GCP. Okay. Bear with me while I type incorrectly. And then, what is this? I missed something? Oh, there, look at that. Thank you. All right, double check. It's the first time I've screwed that up on all my demo runs. I've made other mistakes, but not that one. All right. Look at that. A thing of beauty. So now we have 4 services that our environment knows about that we can now create. So let's just spend no further time. Let's create an instance. Let's create the PubSub instance. Now the interesting thing that I will show you here is that when we create a binding to it, so we want to bind to it from our application. And we still want to use the same application. And I'm going to now type some parameters. Remember earlier when I said that we will have schematized parameters in the future? Well, that's the future. So right now I got to type in some ugly JSON. So it's a very small amount of text. And so this is just setting the permissions on that. Does that look right? I think it does. All right, so we'll create that binding. So now I've said I want to bind my application to that, but the application doesn't know how to talk to PubSub yet. And so for purposes of making this a shorter demo, I'm not going to make changes to the code and recompile, rebuild my Docker image and everything like that. What I've done, or actually what one of my engineers did, was basically make it optional so that we actually we have the same code and it just knows it's passed a parameter that says whether it should use PubSub or not. So here's the code for that. And so I just need to make a change to the YAML file. That is one of our config files. Save that. And now if I update this application, we should be able to see some action on that deployment again. All right, so kube control get pods. Take a look at what's in here. Oh, you see one is terminating, another one is running. So it looks like we're up in business again. Where did I leave that window? Demo. Nope, that's bash. What am I doing? Oh, that is surprising. Oh, there we go. All right, so let's buy a couple more books. Let's buy this one. Let's buy this one. And now let's go back here and run a gcloud command. So I'm going to call gcloud to basically fetch from the subscription channel. It's called GCP Next. And ideally, everything works and we get something back. Here we go. Okay, so there's a purchase that was made. Let's see if we have another one. Different message ID. Not very exciting. Let's see what else we got. That was it. I made 2 purchases. All right. So that's that piece. And I'm just going to... All right. So now I'm going to hand off... No, I need to go back to slides, please. Can we show the slides on the screen? Perfect. All right. Okay, so what are some of the key takeaways? This is the app that we modified, and we showed how we can easily connect to pre-existing services from a new app, and also how to provision and connect to a cloud service in the same way. One of the existing services, the payment service here, we didn't actually deal with that, but what's interesting is that it's actually exposed as a service as well. And so there's a way that you can wrap existing legacy things as services, and those of you familiar with Cloud Foundry will recognize that same capability. And so a lot of the benefits that you're going to see, especially in Louis' part of the talk, are then applicable to something like a legacy service like payments as well, because it now gets wrapped in this abstraction. We also showed how we needed no knowledge of where the service came from or how to negotiate credentials. The necessary information just showed up in secrets and then environment variables. Now, let me hand off to Louis, who will show you some even cooler stuff.
All right. Thank you, Martin. Let's see. Okay, so Martin talked to you a lot about how people are going to acquire services, how we're going to make sure that services have well-known relationships with each other. And now I'm going to show you some of the things that we'd like to do underneath all of that to help make that work better, and to help you get some insight into how those services are talking to each other and be able to start imposing policies on the conversations that those services are having with each other. And there's a term floating around nowadays that I think is gaining some momentum for all of this, and it's the service mesh. Right? You have lots of these services that are all talking to each other. It's not a network in the traditional packet sense. It's a network of services and their relationships with each other and all the things that they want to do. So I think of a service mesh as a network for services. So let's talk about that a little bit. There we go, wrong button. So what would you want a network of services to do for you? Well, when we build services today, we want reliability. We want them to perform well. We want them to be able to deal with transient failure modes. Maybe if I bring up a service and it's talking to some other service, and that service has a failure mode, maybe I can't reach it, or maybe one of the jobs goes down, I'd like the network, the service mesh, to take care of that for me. We'd also like the service mesh to help us with performance. When I bring up lots of jobs, and maybe I'm bringing up stateful jobs and stateless jobs and doing all these types of things in production, routing traffic to a stateful job when it hasn't had time to warm up its cache is probably a really bad thing to do for latency. And it might even be a really bad thing to do for availability if cache loading is a very expensive operation and you start to get these cascading failure modes. We also want the network, the service mesh, to help us with visibility. I'd like to know which services are talking to each other. I'd like to know if there are services in my deployment that I don't expect to be there. So we'd like to have a lot more visibility about what the behavior is in this network. And I'd like to have control. Right? When a service is talking to another service, it would be very nice if I could go and interpose in that flow and say, no, you're not allowed to make this communication. You're violating some corporate policy, or you're using too much of a resource, or doing these types of things. So how do we make all of that happen? Can we switch back to the demo? So meanwhile in Opsland, okay. So while Martin was doing all these wonderful things, one of the things we also spun up in the background is some monitoring. Right? So all the services are talking to each other, they're generating traffic. Oh, wait a minute. Do we switch to the demo? Thank you. So here's a typical Grafana dashboard. It's showing you the traffic between the services. We're showing you a simple kind of request per second metric. And you can see that we've annotated the graph with the services, right? So you know that the Books services, the Books FE service is talking to purchases, is talking to users. And for some really strange reason, it's doing 60 QPS of traffic. Martin? This is the apps guys running load tests in production again. Okay. All right, well, let's go stop that, because that's just bad practice. And that looked like it was that was the Books front end. Let's see. Books front end talking to the user service. And Barton definitely did not buy 50 books a second. So let's go deal with that. So we go back to our instances. And we can go look at the user service. All right, we see we have our binding. The Books front end talking to the user service. Okay, so let's dig in there. And notice this link, add network function. Right, so this is very rough. This is very much demo, alpha quality stuff at this point. But if I go in here and say add network function, I can start to take some action on the interaction between those two services. And in this case, I'm going to impose a quota. And I don't think Martin really wants to buy more than $5 a second, 5 books a second, so I'm going to turn that on. Now what happened under the hood, right, the system is aware of this binding. It's going to take that notion of relationship and it's going to push a piece of configuration down into a system and say, hey, for this binding, this relationship between two services, we want this quota. All right, so let's hop back on over to the Grafana dashboard and see if anything happened. And look at that. Right, we've seen the error rate start to spike up. Right, the Books front-end services, or this load test that Martin is running, is still sending traffic, but now we're rejecting it. Right, it's getting dropped. And actually, it's not even going into the service itself. It's being dropped earlier in the network. And so we're seeing the requests will actually start to cap out at 5 QPS, the valid ones, and all the other traffic is going to get rejected. There are lots of these types of things that we can do in this network if we have this amount of information, if we're able to interpose in the traffic in sensible ways. So how do we do this type of thing? And can we switch back to the slides, please? Although Grafana is very pretty, we could look at it for another few minutes if you like. Yeah. Can we go back to the slides? Thank you. All right, so how do we do this? Well, the first thing that we need to do is we need to capture traffic. We can't really do anything if we don't know what's moving around. So here's a little subset of the application. We have the Books app, and we have the user's service. And the Books app is calling the user service via its API. Well, one of the things that we did before Martin started driving the demo is we installed a component into the Kubernetes cluster. Right? This is part of the Istio project, which Martin alluded to earlier. And it's called the Proxy Manager. And what the Proxy Manager does is it listens to the Kubernetes API, and when you spin up pods, it rewrites the pods on the fly, and it injects proxies into them. And then, it also rewrites the networking rules inside Kubernetes. So instead of that traffic going directly from the books front end to the user service, it's actually going through proxies. And it's going through a proxy on each side. And we'll talk a little bit about why we do those types of things. So now that we're capturing traffic, we can start to do interesting things with it. Right? We can start to inject network functions. Right? There's different classes of network functions, but we'll talk a little bit about some of them here. Maybe you want to roll out a new version of the user service v2. If you don't want to send all of the production traffic to it live, right? Maybe you just want to send 1% of the traffic. So you want to qualify that service in production and make sure that it's stable before you cut everything over. The proxy that was injected into the Books FE pod can now start to split the traffic on your behalf. And you can do this at the operator level, right? You don't have to go and change the application code to do this. This is a very important thing. Maybe the user service is unreliable. And so instead of the Books app having to deal with the fact that its calls to the Books user service are flaky, the proxy can actually do the retries on behalf of the service itself. Right? So as long as the proxy has some awareness of what type of operation it is it idempotent, is it safe to retry, it can actually do these things on your behalf. And so if you have a system where you have these kind of intermittent flakiness, but it's not due to anything that you can directly control right now, as an operator, it's very often the best of bad choices to start turning on retries with exponential backup. Maybe you want to move the service up into the cloud. Right? Maybe the user service is this vast, enormous thing with hundreds of nodes in 7 different regions. And now you want the proxy to do smart, intelligent things on your behalf, like load balancing. Right? Maybe that load balancing is going to be regionally aware. Maybe that load balancing, you might want that load balancing to do something like optimize for latency. Right? So you're going to send all of your traffic to the most local node possible until it starts to fill up, and then you'll start to shard it over to some other region. Or maybe you want to maximize for availability, and you just kind of keep an eye on the back-end health of each service, and the proxy can be aware of these things. Now, it's worth noting that we didn't have to rewrite any application code to do this. As Martin mentioned earlier, the Books front end was written in Node.js, and the user service, maybe it's written in Go, and the purchasing service is written in .NET, and all these things. So this big, complex polyglot environment. Implementing sophisticated network functions like these is pretty expensive. It actually takes a lot of engineering effort to get it right and to do it consistently. And consistency is what really matters here. Right? If one piece of this network doesn't really play well, you can start to have nasty things happen. You can have cascading failure modes. And so having the proxy do this work on your behalf is actually massively beneficial. Right? As long as it's consistent and it does them well, you don't have to worry about the application developers consuming some fancy network runtime, trying to write exponential backoff code for the 15th time. Right? You just don't want to be doing those things. So what else can we do? Well, we can inject identity. So another piece that Istio installs into the Kubernetes cluster is a certificate authority. And when we bring the proxies up, we also inject credentials into them. Those credentials, in the case of Kubernetes, are tied to Kubernetes service accounts. Now, the proxies can use those credentials, those certificates, to enable crypto between the proxies. Right? So we can do mutual TLS. Right? So now, both applications, both nodes of this graph, can strongly verify who's calling them. They know it precisely. It's not just some random piece of code running in my cluster. No, it's something running with that authority. Even if the user's application isn't written using some standard protocol, maybe it's not using HTTP, right? Maybe it's a database with its own proprietary binary protocol. So maybe you can't tunnel the identity all the way down into it because its protocol doesn't matter or won't let you do that. But at least you know that traffic between those two nodes is secure and is tied to that identity. And if it's tied to that identity, we can start to do some things with it. We can start injecting policy associated with it. Right? Maybe the Books application is owned by Martin's development group, and maybe the user service is owned by my group, and I think his development team is a bunch of cowboys, and I'm just going to shut them off. Right? I can do those types of things. There's lots of interesting things we can do with policy. So another component that gets injected into the Kubernetes environment is this thing we call the mixer, and it can do a wide range of things. So what I showed you earlier, we showed you monitoring, right? We inject this component, and the proxy is sending all this information to it about the behavior of the network. And we simply flowed that into Grafana, right? We flowed it through Prometheus into Grafana, and we had some nice dashboards and things like that. And I can visualize my network and the behavior of the services between them. And we could have done it with Stackdriver or some other monitoring tool. We also did Coda, right? And in the example that I showed you, we have a Coda component running inside this. And on the user side, it said, hey, I'm supposed to enforce 5 QPS of Coda, and it just prevented the calls on that server-side proxy. It prevented them from actually getting into the user service. And if there was mutual trust, then we could have actually done that check all the way back up at the book side, and the traffic would never even hit the physical network. But in worlds where you span multiple trust boundaries, you really do need to make sure that you enforce ACL-like checks, in the same trust domain as the service. We could also have done authentication and ACL. Right? So maybe that you have multiple authentication schemes in your network, maybe using OAuth or SignJots or who knows what. And those credentials are flowing through, let's say, HTTP calls. You can delegate them out to this service, and it can make sure that they're consistently enforced across the network. And also you can enforce ACL policies, right? If I have that notion of identity, whether it's a mutual TLS identity, maybe it's the Kubernetes service account, maybe it's something else. Doesn't really matter, right? You can use that to perform ACLing checks, and a lot of companies out there have standard ACL policy systems, and you can use this to integrate that. And this is probably the most important point, is that this system is easy to customize. Right, so what we've really done is set up a framework where we provide a whole bunch of standard signals about the traffic flowing between services. And then we provide this convenient runtime integration point where you can go and put control over that traffic. Right, so we will know which service it came from, which service it's going to, what the operation is, what region it came from, what credential or identity does it have, how big is the thing. Right, you can enforce whatever policy you want. Right, so this mixer thing, the current implementation is written in Go. We think Go is a good language for people to write extensions in and to plug them into this framework and then just deploy it into the cluster. Okay. So in conclusion, we have our principles, and Martin talked a lot about these at the beginning. And the big one being services, not infrastructure. Right? What we're trying to focus on is services as units that you can find, acquire, consume, and then operate, right? And not the lower level building blocks necessary to do all those types of things, right? Bringing the level of abstraction up. We talked about interoperability, and in particular with the Open Service Broker API, right? It's a community effort, and we showed you a way to bring services from other environments into your workplace, right? I had my own catalog, I could take Google's catalog, I could take some other vendor's catalog, bring them in and start to work with those things. Or maybe as an internal thing, right, I create my own catalog and I curate it, and that's all that my internal developers are allowed to use, and there's this qualification process to get things into the catalog. And then we talked about automation. We want to make sure that everything is automatable. Right, so we walked you through our UI, and we showed you a bunch of command line stuffs, and I did some things, to enforce policy, and then I showed you some of how that worked. But everything here is driven by an API. Right, so if you want to change the policies around how services talk to each other, you make API calls to do that. Right? You probably need to have a lot of privilege to do it, but that's what you should be doing. And so you can start to automate the rollout of services, automate the acquisition of services from third parties, and do all these types of things. This is entirely open. This is a collaborative effort. Right? Google is not doing this on its own or anything like it. Right? So Martin talked about the Open Service Broker. He also talked about the Kubernetes Service Catalog. And I talked a little bit about the Service Mesh and Istio. And these are the companies that we're working with on a daily basis to make that stuff happen. So here's some useful links. Right? You can go and follow these links, read about this stuff. As Martin warned you at the beginning, things are alpha, sharp, pointy, dangerous, borderline unreadable. Maybe you have to read the code to figure out how it works. It could be quite painful. So hopefully the next time we give this talk, there'll be nice shiny docs when you go follow these links, and everything will be entirely understandable, and you'd all be using it, and you wouldn't need to ask me any questions.